Our next speaker is Bob Rucker. He earned a MS degree in nuclear engineering from the University of Michigan and professional engineering certificates in nuclear engineering and in mechanical engineering. He worked for 38 years in the nuclear industry, performing nuclear analysis computer calculations for the design of nuclear reactors, criticality, safety analysis, and statistical analysis of experimental measurements. Since 2013, Bob has been doing research and presentations on the Shroud and has written 39 papers, including papers number 33 and 34, to explain the carbon dating and image formation. And those are available on the research page of his website, shroudresearch.net. Let's welcome Bob Rucker.
Thank you, Joe. Yes, thank you for the introduction. Good to be with you again. Let's get started then. So the one important point here is that what I'm going to be talking about now is what I've been talking about since about 1914, because it's based on the calculations that I did up through 2014. So at 20, what did I say? No, that's not right. Thank you. Can you move up here? No, 2014, yes. So there's so many things going through my mind here. Please excuse me. I have enough trouble just keeping up with myself, let alone everyone else. So anyway, 2014 is when I did these previous calculations, and so that's what I'm going to be talking about today, because I wasn't doing calculations between 2014 and this year. So I did restart the calculations about 5 months ago, and so I'm going to be talking about those new results in the next one at 2 o'clock over in the other room. So that's where I get the more significant results. So this is going to be based on the calculations I did in 2014. Okay, good. We had the introduction. Been working 12 years in Shroud research, 38 years in the nuclear industry. Let's move forward. My presentations, I'm now on the, let's see, the second one. So the third one is going to be over at 2 o'clock here. Please don't miss that. I'm just going to go through some of these fairly quickly so that you're familiar with the nucleus is at the center of the atoms, the electrons going around the outside. The nucleus is made up of protons and neutrons. The protons are positively charged. The neutrons are neutral. So the carbon-12 then has 6 protons and 6 protons, six neutrons and 6 protons. Carbon-14 has 2 additional neutrons, so that it does decay with a half-life of 5,730 years. So in the first half-life, you have 50% left. In the next half-life of 5,730 years, you then have 1/4 left, etc. So that allows them to do dating. Now, so in carbon dating, I think we've covered this to some extent already. So the samples must be representative, and the contaminants must be removed by cleaning. So in my assumptions, I am assuming that what I believe to be true, and that would be that the equipment at the laboratories correctly measured the carbon-14 to carbon-12 in the samples that they were given. That's just indication that the equipment was operating properly. The individuals were not cheating or intentionally trying to alter them, and that the chemicals and everything else that they were doing was reasonable. And they typically do control standards in order to validate their analysis of the original material that they're trying to do. And they validated their equipment and procedures and any chemicals that they were using in the process by dating the control standards to reasonable values. So I think that it's most reasonable to assume that they correctly measured the carbon-14 to carbon-12 in the samples that they were given. Now, the issue here is that the assumption was always made in carbon dating that once they accurately calculate the ratio of carbon-14 to carbon-12, you then have to you'd like to get to the date. Now, the rather simple equation that's used to translate the ratio into a date assumes that that ratio is only changed due to decay of the carbon-14. So in my work here, I'm assuming that that assumption is incorrect, so that it's not legitimate to use that simple equation, because if you have brand new carbon-14 being produced in 33 AD due to the resurrection, this is a very small side effect going on of a radiation burst in the resurrection, so that you would have an increase of 16.1% in the concentration of carbon-14, which then decays with the normal half-life. So those people who actually did the analysis then, of course, 95% would be naturalists. They would say, okay, the cloth is just a normal piece of cloth, nothing special about it in all of its history, so that therefore it can be dated just as our normal process. In other words, there was no resurrection, it was not covering the body. That's an assumption of naturalism. And I don't think it's legitimate to make those assumptions, but that's what they did. And so when they measured, I think it was 91.57% of what's normally present in the carbon-14, they then projected it back to 1260 is where it crossed the 100% mark. And I'll show you that. So that's how the carbon dating is done. So in 1988, they measured, they sent the samples to 3 different laboratories. They were cut into subsamples. So we ended up with 12 different subsamples being dated. The average, they brought those 12 subsamples down to values for each laboratory, then averaged those results, came down to 1260 plus or minus 31. Those are the uncorrected dates, 1260 plus or minus 31. Typically then you would correct it for the change in carbon-14 concentration in the atmosphere. And so that's when you get the 1260 to 1390 with a 95% confidence limit, but that 95% confidence limit is based on an absolute certainty in your value of 1260 to 1390. If you're not certain about that, if the data should be rejected entirely, which I believe is true, then the range of 1260 to 1390 with a 95% confidence should simply be rejected. Okay? This has no bearing to reality. Yet, you can still use the carbon dates that were calculated, because there's a one-to-one correspondence between what they calculated, even though they ought not to have used the equation. But they did use the equation, but there's a one-to-one correspondence between the date that was calculated and the original carbon-14 to carbon-12 ratio. So you can still use the dates that were calculated, even though we reject them as being not valid to guide us into the age of the cloth. So that there were, I would say that there's 12 different date indicators that contradict the carbon dating. So we have 7 of them here. We have the coins dating containing the images back starting at about 692. We have the paintings starting about 550 AD. There's various different date indicators over the next group here up through 12. Number 10, I think, is the most interesting, and that is that when they cut the 3.2-inch side piece off the cloth, and it may have just been a mistake in manufacturing. There's various cubits, lengths of cubits for different areas. Maybe the man doing the cutting just grabbed the wrong cubit, measured it wrong, cut it off. The boss comes in and said, "What are you doing? You did it wrong. What are we going to do now?" "Well, let's cut off a little bit more." They cut off a little bit more, sewed it back on. That's a good explanation. Maybe that's what happened. Who knows? But anyway, it looked because the stitches are so continuous across that seam, it looks like it was the same material and was originally connected. But then the stitch which connected them is of importance because it's a unique stitch, most similar to a stitch that was found in Masada that was destroyed in 73 to 74. So that stitch dates the cloth to the 1st century. And I like that. Okay. And then we have, switch here. So we have multiple more modern dates. Over here along we have the date along the x-axis. The width of this is representing the carbon dating between 1260 and 1390. This is where the carbon dating is. Over here is where Jesus' death is, about 30 to 33 AD. Okay, and this is a slide that was shown by Michael Kowalski in Brescia at a conference in Brescia, Italy in 2023. And so then we have the 5 different measurements from 4 different methodologies. There was actually a mechanical test on both the wrist and the pelvis here. But what we have here is the more modern measurements. The things of significance here is that they all contradict the carbon dating. Okay, now you might object thinking, well, these aren't well proven. You know, there were new measurement techniques invented to measure the date of the shroud. So they're not extensively used. They don't have a lot of validation. Okay, but there's a consensus here of conflict with the carbon dating. And the most recent is the Wax's wide-angle X-ray scattering test. And that had a smaller 1 sigma standard deviation on the measurements compared to the others. And it agreed with the date for Jesus. And I like that. So all of that in background, I think, gives us additional confirmation that the carbon dating is correct. So there's been multiple different explanations for the carbon dating over time. I think the first that was documented was neutron absorption produced by new carbon-14 being produced from the neutron absorption. And that was by Tom Phillips. My wife and I met with him and his wife in his home and talked about this a few years ago. But I think, you know, give him credit for having the courage to publish that in the letters to the editor in the same edition which published the 1988 carbon dating in the British journal Nature. So I think that was the first documented explanation. But it could not be followed up on until I did the nuclear analysis computer calculations starting in 2014. So it just had to wait. That confirmation or those calculations had to wait. I wanted to do it, but I couldn't because I didn't have a computer code that was fast enough. I didn't have a computer that was fast enough, and I didn't have the time. So all that finally came together about 2014, which I then reported at the conference in St. Louis, here in St. Louis, in 2014. So the second there is contamination from handling wax, talc, etc. I think that the cleaning methodology that they used were very severe and should have been thoroughly cleaning the material. They would sometimes end up boiling the sample in acids, mixed acids, and thus even ending up with a minority of the material remaining, so that, you know, most of it's been cleaned away. So smoke and heat from the fire in 1532. You know, to change the sample carbon date due to smoke, for example, carbon from the smoke, you'd have to have a range of maybe about 80% contamination on the sample, because you'd know the date for the fire was 1532. Contamination from 1532 mixed with original material from 33 AD. In order to bring it up to 1260, the sample would have to be mostly contamination, 80% contamination. Well, that's not true. I mean, you could see it with the naked eye. So that's one of the reasons why, and the good cleaning that ought to have been done, and I believe was done, has just, I think, eliminated number 3 as well as number 4. Bioplastic film. And so number 5 is the most common explanation. I think carbon 6 has already also been rejected here, carbon monoxide, when it was fairly recently after it was first recommended. There were discussions of that, and there were people went to confer with experts on this issue, and it was generally rejected. So what we're left with here is the number 5, the invisible reweave, and number 1, neutron absorption. So of course I'm the proponent of neutron absorption. I will also mention here that we have a chemist from Mexico City, professor from Mexico City, that's going to be talking on evidence against the invisible reweave coming up. So you might notice that. Gudinez/Rucker. So I'm going to be giving some background to that as well. So we have various proponents of the neutron absorption hypothesis. Now, it's never been the majority hypothesis, but it's a long-standing hypothesis. So we have Lindner starting about 1988. We have Tom Phillips in Nature, 1989. We have Jean-Baptiste Renato, 1990. We have Moroni and a couple others in 1998. We have me starting in 2014, Mark Antonacci, Art Lind, etc. Tom McAvoy, etc. So that, it's a common concept to be discussed. Okay, so what is the neutron absorption hypothesis? Well, if neutrons were included in the burst of radiation that produced the images, now I think the majority of serious shroud researchers believe that the images were made in some sense by radiation. They differ on how. But so what I'm suggesting here is that if the radiation burst that formed the images, if it also included neutrons, then a small fraction of them, probably 1 in a million, okay, would have been absorbed in nitrogen-14 in the shroud to produce new carbon-14 by a well-established mechanism. There's no doubt about this mechanism. So nitrogen-14 plus neutron in the red goes to carbon-14 plus proton. Just think about it. Nitrogen-14 has 7 protons and 7 neutrons. 7 plus 7 is 14. That's why they call it nitrogen-14. So it absorbs a neutron. That then goes to 8 neutrons. But in the process, that's unstable. So it immediately ejects a proton, changing from 7 down to 6 protons and 8 neutrons. What is that? That's carbon-14. Okay, so it produces carbon-14 in the process. And this would cause the shroud to be carbon-dated younger than its true age. It might have an apparent carbon date. But is that the true date? That's the question. I believe it's not. So the basic assumption of the 1988 carbon dating that I'm considering here, the Shroud of Turin is a normal piece of cloth. I mentioned that. That'd be false. You have to assume that in science, if you have possibilities, you have to check them out. So if Jesus' resurrection is true, just logically thinking, if it's true, then how did that process take place? Well, we have no idea. Could it have included radiation, even as a side effect, a small side effect going on? Well, you don't have any evidence for or against it, so it's a possibility that needs checking out. It can be carbon dated as any other piece of cloth. Well, I don't believe so, because if it was the shroud that Jesus was buried in, and if the resurrection is true, then there's certainly the possibility that the process by which the atoms in his body made a transition into an alternate dimensionality that some people would like to call heaven, okay? It certainly could have had some effects on the cloth, so that they assume that nothing unusual could have changed the carbon dating. Well, I think all of that is not even being scientific, because the founders of science, they were Bible believers, and they said, we want to determine how God did it. So they weren't naturalists, not at all. Okay, so this is when they did the experiment, this is what they would have measured. They would have said that the cloth starts at 100. Let's call it 100% of normal carbon-14 content, 100%. And so, as 95% of the scientists are naturalists, you can't go over 100%. So that when they measured 91.57% of normal 100% carbon-14 that they measured in 1988, they projected it back. You can't go over 100, so bam, they bring this down. It's 1260, plus or minus 31. That's how they get the answer. But what I'm saying happened is this, that there was a burst of radiation at this point, including neutrons, that increased the carbon-14 content by 16.11% to change the date from 33 AD to a measured value of 1260. So that the carbon-14 then decayed, as is normal, to that point, so that they were only aware of the black area and not the red. So that's the difference in what they're assuming and what I'm assuming. Okay, got it? So they cut the shroud at the corner. If you're holding it horizontal with the front image to the left, then this would be the upper left corner. If you're holding it vertical with the front image at the bottom, then this would be the bottom left corner. But that's a picture of them cutting it, so that what we're talking about is them cutting it from right up here. This, again, is the backing cloth. So this was just right up next to the backing cloth, and that's been shown previously. But this is the corner off the feet of the front image, for example. So that's, and then this is my diagram. So whenever you see this, I drew this. So that's not too bad. I just recently changed. I had positioned A2 here. I've moved it over to here. So I think it actually came from that location. And I think Joe Marino, I talked to Joe Marino about this, and he agrees with me on that. So what we have A1 went to Arizona, so the A for Arizona, Z for Zurich, O for Oxford, and then A2 here. This one went, when it was sent with A1 to Tucson, this one immediately went into the vault. It's there today. Okay, let's move on. Okay, so now you're probably familiar with the fact that there are two different kinds of errors. So that if you're doing measurements, there's a random error. Can be a little bit high, your measurement can be a little bit high, a little bit low than the next time. But if you do enough measurements, then the errors, either high or low, tend to compensate each other. You take the average of many measurements, and you can come up with the mean value of the peak of this distribution. So we're not really worried about random error because we can deal with it by taking many measurements. The problem is in what they would call a systematic error, where all the measurements are changed. In this case, I'd rather have a diagram which shows the systematic, which shows this peak over on this side of the true date, changing from the true date to increasing the carbon date, because that's what would be happening here. Okay. Any questions on that at all? Okay. Let's move on. So a systematic measurement error is caused by something that changes the average measured date from the true date. In their analysis, they assume that the shroud was a normal piece of cloth. But if Jesus' resurrection is true, then radiation, possibly including neutrons, may have been emitted from the body. These neutrons would have produced new carbon-14 on the cloth, thus shifting the measured date forward from the true date, so that the neutron production in the cloth would be what would constitute the systematic measurement error. So it would change the mean value of the measurements from the true value. And that's the way I like to think of it. People can think of this differently. They can say, well, it's heterogeneous rather than homogeneous. They could also say that when they did the measurement, they weren't measuring the true date of the cloth. They were measuring the true date of the cloth plus the new carbon-14 that was produced by neutron absorption. I think that's what they were really measuring. They weren't measuring what they thought they were measuring, in other words. Okay. So let's go into the dating results are published in the paper by P.E. Damon plus I think it was 21 others. But Damon was the first name, so it's simply called Damon commonly. Published in Nature, which is a very respectable, supposedly, British Journal, Science Journal, 1989. The title is Radiocarbon Dating of the Shroud of Turin. So paragraphs 1 and 28 include the comment here that the results provide conclusive evidence that the linen of the Shroud of Turin is medieval. Now, Bray in Turin then, who saw the results, he said, you haven't proven this. You need to remove that statement, but they didn't. Okay? That's my understanding of it. So the main error, as I see it, was on paragraph 23. So I labeled the different paragraphs. I counted. So you can do that. It is unlikely that the errors quoted by the laboratories fully reflect the overall scatter. Okay, that's what they say. Well, why would that be true? Because there's a systematic error. They're almost admitting that there's a systematic error that changed the measured value from the true value. That's what this statement's. Yet only allowed for random measurement errors in their analysis. Isn't that interesting? And the statistical analysis they did on the three control standards, they did change it, the statistical analysis methodology, they changed it to analyze the shroud. Well, when they changed the methodology, how can the analysis of the control standards then validate the accuracy of the measurement if you're using different statistical analysis techniques? Okay, very interesting. All the problems that are in this. So the quote from Harry Gove, I think, has to be taken into account at this point. Very important. Now, he invented the AMS technique, accelerator mass spectroscopy technique, to do small sample dating of materials, including the carbon dating of the shroud. Why did the laboratories want to do carbon dating of the shroud? Were they that interested in accurately getting the date for the Shroud of Turin? No, they really didn't. I don't think they cared about that. What they wanted to do was to validate their small sample dating technique against the known date of the shroud. Okay? I've often heard this story, that if you take a sample in for carbon dating, the first question they ask you is, how old is this? Yes. So in other words, in order to validate their small sample dating technique, they had to know what the date was before they did the measurements. So what's the basis for that? They assumed that it only originated at the time that it was shown in Lorey, France. And that's just an assumption. There's many different evidences that it was prior to that. But that's what they had to assume. You see all these problems. But this is what he said. It is a well-known fact that scientists can produce whatever result they want. If you believe that passionately in something, you can steer the results. My God, we've all been guilty of that. Well, that's like my acquaintance. I had finished my physics lab first year in physics at University of Michigan, and I couldn't get I followed the agenda, but I couldn't get the experiment to agree with the theory. So I had to write it up that way. I got a C on the paper. So I was leaving, walking with someone I barely knew, and I was telling him about my story. I couldn't get the answers to agree. He said, well, I did. I said, how did you do that? How did you get him to agree with the theory and the experiment to agree? And he said, oh, it was very simple. I lied. Yeah, science is done by human beings, right? Can human beings lie? They have multiple different reasons to do so. Okay, and this is good. My God, we've all been guilty of that. Now he accuses everyone else of doing the same thing. I don't think I've ever done that, but I assume he has, because he assumes everyone else has. Okay, it's a well-known fact that scientists can produce whatever result they want. If you believe that passionately in something, you can steer the results. So the question is, did they steer the results to get the values that they wanted to validate their small sample dating technique? Because you know why? There's big money in it. Okay? If your statistician doesn't give you the results you want, out. Bring in another person who's willing to do what you want. That's why Chernobyl exploded in Russia. Okay? You can see what ended up there. Okay, so here's the dates. So Oxford had three samples, Zurich 5, and Tucson. Now the values from Damon, the report that was published in the British journal Nature, are in the green. Okay, and then my calculations are in the red. So here's, they calculated, they bring it down an average for each laboratory. Now, each experimental measurement produces two values, the value itself and the uncertainty. Now you might say, well, uncertainty is not important. Let's just go with the value. Well, no, the value tells you what the uncertainty tells you what the value means. And depending on the values and the uncertainties, it can tell you to reject all of the values because of the presence of a systematic error. Now think if I give you a ruler and I tell you to go out here on the pavement somewhere and measure between 2 points. And so you do a measurement and you take the ruler and you put your finger down, you move the ruler, you put your finger down, move the ruler, put your finger down. Long sequence of measurements that you do. And you bring back the number to me and I say, do it again. Do it again. So you eventually come back with 12 measurements. And then I say, what is the value between those 2 points? So what do? You take all the values and you assume that there's a little bit of random error by doing this sort of thing. And so you take all the values and average them. But then I tell you, this is not 12 inches long. Okay? So that there's a systematic measurement error in the average value that you told me. And so they say, well, tell us how many inches there are there, and then we can correct the answer that we gave you. And I say, I'm not telling you. So in other words, there's a systematic measurement error, but you don't have a clue as to what that systematic measurement error is. What is the only thing you can do? Throw the data out. Okay? If there's a systematic measurement error and you can't correct for it, the only thing you can do is to throw the data out. And that's what I say they should have done. So anyway, when I did the measurements, let me back up. So if you average the three different laboratory values, you come down to the 1260 plus or minus 31. Then when corrected, it comes over to the value of 1260 over here. So my measurement, my analysis, and I'm assuming just a normal or Gaussian distribution. And so they say that they were using a t-distribution. I'm not sure exactly how to factor that in. But the point here is that if you look at these values here, the average here and the uncertainties is 55. When you average it together, you have to reduce the uncertainty basically, as it turns out, by the square root of the number of measurements. So the 55 then is reduced by about 1.73, square root of 3. Here, the average is about 54, but it's reduced by the square root of 5, which is 2.24. So that turns out right. Here, if you take the average here and reduce it by the square root of 4, which is 2, that's easy enough, what you come out with is about 17. So why is that 31 there? Isn't that interesting? So over here, if you take these three values, well, what's the average of that? Maybe 20, 26, 27, 28. Divided by the square root of 3, 1.7. Why does that come down to 31 here? There's strange things going on in this analysis. Okay? Don't know. Anyway, the other strange thing here, on the bottom, I hope you can see this, but here's the three different control standards. You have a 90%. This is the significance level of the confidence you can give it this. 90%, 50%, 30%. Yeah, you can trust those values, and the dates turned out to be consistent with what they expected. But over here on the Shroud, they published a 5%. Now that's only one digit. If they went to 2 digits, what would that be? 4.8? 4.4? 1.4? What is that? Anyway, they show the 5. Why did they show 5? Because in statistical analysis, that's the minimum you're allowed to have. So they had to achieve that. Okay? But they did. They achieved it. Valid or not. We're waiting for an analysis by Marco Riani and Paulo de Lazaro at this point. It's been turned in for a peer review, and we're hoping that it'll be coming out pretty soon. Now, here are the 4 different papers after the information from Tristan Casabianca came out in 2017. There were 4 different analyses in peer-reviewed journals that all concluded that the samples that were taken were heterogeneous, not homogeneous. Now, what that means is that it's like dating. If you want to date my shirt, but you take a sample from his shirt, okay, that's heterogeneous, okay? You know, why would you do that? His shirt's not my shirt, you know. So that's heterogeneous. So the samples don't agree with each other, in other words. And that's what these 4 different peer-reviewed journal papers concluded. So, for example, if you take the value from Tucson of 1303.6 plus or minus 17, yes, and subtract off the Oxford value, here we go. Here, now these are my values. I'm adding one additional digit onto it just to avoid round-off error in later analysis. Okay, something I typically do. I don't want to create problems that aren't there, in other words. So the difference here is 102.8. But in calculating the uncertainty here, what you do is you take the square root of 17.1, or the square of 17.1, you add it to the square of 30.7, then you take the square root of it, that's 35. But then the significance here is that the measured difference divided by the uncertainty gives you what's called a 2.93 sigma difference. That's greater than 2. So therefore, you conclude that there is a statistically significant difference between the 2 laboratories that are only separated about that much, you know, over that little length. Why would that be the case? Something is going on. Okay? Okay, so then if you take the values that were obtained and then associate them with the center of the sample of the three different locations, you can then plot the data as a function of the distance from the short end of the cloth. Okay, and so what we get then is this curve. And so I'm showing the 1 standard deviation on each of those measurements according to my calculation. So what Damon did in their analysis was they just, you know, because the shroud is just a normal piece of cloth and nothing unusual could have happened to it. So therefore, they just added the 3 values and they said the average is 1260. That's where the 1260 comes from. But you notice it only goes through 1 point. It misses the other 2. Isn't that interesting? So your better curve is this. You notice the coefficient on this best fit line is 35.887. If I go back, okay, over here, carbon date increases by 36 years approximately per centimeter, which is 91 years per inch. So that if you move your sample point 1 inch, then you get your carbon date would be 91 years higher at that rate. If you move your sample point 10 inches, then you date the shroud to the future from today, because you're adding 910 years to 1260. Okay? Very interesting what you can do. And you know, you say, well, that's impossible. Well, yeah, that's the point. That's the point. But it's just the result of using your wrong equation that's no longer valid on the data. So you can actually produce dates way into the future because the amount of new carbon-14 is much greater than the original amount of carbon-14 that was in the sample. Question?
Wouldn't a better fit line there be an ellipse, not a straight line?
Well, I just wanted to keep it simple. I'll show you more data in a minute. Okay? Okay, so if I continue that calculation out, and so I'm running with a computer code called MCNP. That's an acronym for Monte Carlo N particle, where N stands for neutrons. This is a standard computer code that's used in the nuclear industry. I was in the nuclear industry for 38 years, running a variety of different computer codes. And this is one of the more recent ones. I had to wait long enough for this computer code to become available in order to do the calculation that I needed to do on this. And I had to wait for the computers to get fast enough. I had to wait 20 years to do these calculations to allow the rest of the world to catch up with what I needed. Okay, so what I'm saying here is that when I do this calculation, I modeled a human body using simple geometrical volumes and wrapped a linen cloth around it in a box shape, put it into a limestone tomb as it would have been constructed in first century Jerusalem, according to Leon Rittmeyer, Israeli archaeologist, who's excavated many of these, he says. And so when I do that calculation, I get this curve. Now, what I'm saying here is that if I'm locating a 0 point here, and I include the body just to help out, give us a perception of what I'm talking about. So I have centimeters, either positive or negative in either direction here. But the y-axis is the carbon-14 date that the computer code gives. So the interesting point here is if you look at these 3 points right here, and if you look at that slope, it's pretty close to the same slope as that. So in other words, the calculations, assuming neutrons emitted from the body, simulate the measurements, the measured values. And I think that's significant. Now, this also shows that every point on the shroud, both front and dorsal images, will give you a different value. By the way, this curve is just for the dorsal image, up the backbone. Okay? So, and the center of the body at that point on the dorsal image would give a date of about 8,500 AD. The right elbow would date to about 4,500. You could get samples there. They're in the little bottles in the vault in Turin. The samples from the left elbow would be about 3,500 AD. Okay. Yeah, so another issue here, not only do you have the mean date, you have the slope of the data, but you also have the distribution of the 12 subsamples. But then I learned that there was also a date on the face cloth. And so at that point I said, but we don't know where the face cloth was. According to the Bible, we just say that there was one. But I can predict where it was. It wouldn't have been, when the body was brought in, the man up at the front of the pit or stand-up area then took the face cloth off. What would he have done with it? He wouldn't have dropped it where he was walking. He wouldn't have put it on the back bench where the body was. He wouldn't have put it on the ceiling or on the walls, where it would have been on either the left bench or the right bench. And if you bend over, you take that off, and your arm falls right about there. He wouldn't have been thinking about throwing it someplace. No, you just absentmindedly place it there because it's the body that he's concerned about. Okay? So I said, that's where I'm going to predict, about 15 to 18 inches in front of the back bench toward the entrance. So when I ran the calculations, I had to rerun them for 5 days or so. This is the right side bench, and what is the about 18 inches? The back bench would have been up here, so this is the right side bench. And what was the value that the face cloth was dated to? About 700 AD, 3 different measurements, about 700 AD. And that's what my computer code tells me. Well, that tells me I'm doing something right. Right? Okay. So in other words, with my computer code, I can obtain the correct mean carbon date. I can obtain the correct slope to the data. And number 4, I can get the right date for the face cloth. The only thing I'm missing at that point in time was to prove that my computer calculation, on the assumption of neutrons were emitted from the body, could produce the correct range and distribution of the carbon dates for the 12 subsamples. So I have a question mark on that one, okay? Because in 2014, I hadn't done that. I've done that now. I'm in the process now, and I'll show you those results in my next presentation. And Okay, so the 1260 to 1390 should be rejected because the technology did not exist to make the front and dorsal images in 1260 to 1390. There's statistical problems with this 5%. There's the 12 date indicators plus the 5 recent measurements, and there's the MCP calculation of the dates for the subsamples. So, questions? Thank you. Yes.
Dr. Rucker, in your heart of hearts, do you feel that there was collusion among the laboratories while the testing was being performed?
Collusion, you know, I worked with engineers and for 38 years, so I have a feel for it. The normal engineers doing the actual equipment, okay, they have a certain degree of pride, they like their job, they're proud of what they do, they would not be colluding. Where you might find an issue of a desire for pressure to be put on to get the right answer would be at the leading managers level. Yep. So that the managers from the 3 different, you would agree with that, wouldn't you? Yeah. So that the head managers from the 3 different laboratories, and they would see the poor lady, one lady doing the statistical analysis, if she brings in a value of 4.4, and the managers would say, well, I'm sorry, go back and do it again. That's not right. That's not acceptable. That's simply what she'd be told. And if she fought it, she'd be told, well, you know, there's other people that know statistical analysis in our organization. Okay? Any comment on that? What do you think? Is that reasonable or not? Yeah, so I think it would be at that level. Okay? Yeah, it's Tristan. Question?
Yeah. Thank you, Bob, for your presentation. I also agree with you that there was a systematic error, of course, in the nature results. So there was a systematic error in the nature results.
Yes.
We can be sure of this, and we can also be sure that they were quite aware that there was a systematic error. And we have noticed also, thanks to the documentation, that Marvin Lees, the statistician of the British Museum, I mean, she tried and tried again to have the right results. So yeah. Right.
Yeah, she tried and tried again.
And yeah, to have the right interval calendar.
What they wanted, you mean?
Yeah, what they wanted.
They tried and tried to get what the managers wanted.
Yeah, due to data dredging, due to, if you do again and again the calculations, then you obtain, a result that is quite coherent. And they tried to obtain a result that was quite coherent, quite with sufficient homogeneity.
Yeah, yes.
That's the point. But I was interested in your presentation with a previous table when we see all the dates that you have, and before that, if you could go back again and again, there, just after this. So my main question will be, why didn't you use the radiocarbon dates? And because if you see these dates, these dates are just from the calendar AD, but that's not, the usual way that we are doing radiocarbon dates, that we are doing radiocarbon dating. We use radiocarbon dates BP, before present.
Yes.
And of course, this interval calendar that you obtain and can't give you the final popularized, this is not, 1260, 3090 interval calendar, which is, it is the interval calendar which is in the conclusion of the Nature article, but it is not, first of all, it is not the interval calendar that they found. They found an interval calendar with a gap between those results. So it is between 1260 to 3010, and then from 1350 to 3089, I think.
Yeah, so I make many presentations to all kinds of different people, and they would seldom be aware of BP in their thinking. They'd be aware of AD.
Yeah,
So what
but I think that-
in my communications, just for simplicity and not confusing people, I want to try and be clear. So I've already converted the data from before present, with present being 1950.
Yeah.
That's a strange.
But you can do it. You can't do it this because, I mean, due to the nature of the slope, I mean, which is irregular.
Yes.
I mean, there is a danger of doing this, I think. So you have to be really careful.
I mean, the conclusions shouldn't be changed just if you change the units.
No.
I'm just trying to communicate in today's typical units, that's all.
I think you have really to pay attention to
Yes, go ahead.
We have one more question. Do you have this?
Okay.
this one?
We're here because in 1988, the mainstream media took the surrender of Shroud's authenticity at face value, which even the church made the mistake that's curators surrendered it.
They didn't know how to deal with it.
But right now, it would seem that the mainstream media is very, very interested in the new data that came out through waxes and the reweaving and theories and so forth. So don't you see really, my impression is that the C14 1988 results are utterly discredited even in the mainstream media. I'd like your opinion on that.
Okay, yes, I think what my work is, conclusion here, in the past, the main objection to the authenticity of the Shroud and thus the resurrection of Jesus, based on the Shroud, is the carbon dating. That's the main objection. So what I've done, and results I'm going to be talking about in the my next presentation, is I have taken that, turned it 180 degrees around, so that the best evidence, or at least one of the best evidences for the authenticity of the Shroud and its evidence for the resurrection is the carbon dating of the Shroud. Because if you consider all four aspects of the evidence, the mean, the slope, the distribution, and the face cloth, then you end up, it can only be explained by neutron emission from the body. And that then validates who it is and what event, Jesus and the resurrection. Voila, things are solved.
Okay. I'm afraid we're not going to be able to have any more questions. Bob, if perhaps you could be outside the hall to
Yes.
answer a few
Yes,
last
right now.
questions,
Yeah,
and
right
we'll
now.
break for lunch, and we'll see you back here at 1.
Okay?
Oh, I'm sorry. I forgot I was supposed to make an announcement. There will be Mass tonight at 5 p.m. in the chapel, right? 5 p.m. in the chapel tonight for those who want to go to Mass.